Hi, my name is Eesha from Gokaraji Rangaraju Institute of Engineering and Technology. Our project is improving K-means for document clustering. We are a group of 4 members, myself, Lakshmi, Pragnya and Karishma, under the esteemed guidance of Dr. Nadella Sandhya, Head of Department Computer Science. First of all, what is data mining? It would be helpful to get a feel for the amount of the data that is being generated nowadays. There is quote from Eric Schmidt, who was the CEO for Google over a decade. Every 2 days now, we create as much information as we did from the dawn of civilization up until 2003. That is, we are in data-rich situation. But the problem is, much of the data is never analyzed at all. A lot of potentially useful knowledge may lie hidden in that data which doesn't get analyzed at all. So we use computational techniques to automate the extraction of knowledge from this massive amount of data. This is where data mining comes into picture. This leads us to the following definition of data mining. Data mining involves the non-trivial extraction or mining of implicit, previously unknown and potentially useful information from the large data repositories. As we are always in the need of better computational techniques for mining of data, we are improving K-means for document clustering. K-means clustering is a method of cluster analysis which aims to partition n observations into K clusters in which each observation belongs to the cluster with the nearest mean. One of the main disadvantages of this algorithm is that different initial partitions can result in different final clusters. There is no guarantee that it will be converged to the global optimum, and the result may depend on the initial clusters. To overcome this disadvantage, in this project, we propose variant approaches for K-means, cross-validations and sampling. In the cross-validation approach, several sets of initial partitions are randomly generated and each set is subjected to K-means algorithm. Cluster accuracy for each input set is computed and the maximum cluster accuracy is found. Thus, it increases the probability of getting more cluster accuracy than the usual K-means. In the sampling approach, we propose to use an algorithm additional to K-means. This algorithm determines the initial patterns. Algorithm includes the following aspects: a new similarity measure which uses a cosine function and a new heuristic function for selecting initial partitions. This set of initial patterns is subjected to K-means and the cluster accuracy is found. Thus, the selection of the initial partitions is no more a problem as it was in the case of K-means. Now coming to the document clustering. Document clustering or text clustering is a process of grouping documents with similar contents or topics into clusters to improve both availability and reliability of text mining applications. It ensures the information retrieval fast and text classification and document summarization, etc. This is the process for document clustering. K-means algorithm. K-means algorithm is known to be efficient in clustering large data sets. This clustering algorithm is the best known unsupervised learning algorithms that solve the well-known clustering problem. The K-means algorithm aims to partition a set of objects based on their attributes of features into K clusters where K is a predefined or a user-defined constant. K-means algorithm uses a similarity measure to deal with the numerical objects and uses a frequency-based method to update the means in the clustering process to minimize the clustering cost function. Existing K-means algorithm. The basic steps for forming clusters using cross validations are as follows. Let x is equal to x1, x2, x3, so on xn be the set of data points and v is equal to v1, v2, so on vc be the set of centers. Step 1. Randomly select C cluster centers. Step 2. Calculate the distance between each data point and cluster centers. Step 3. Assign the data point to the cluster center whose distance from the cluster center is minimum of all the cluster centers. Step 4. Recalculate the new cluster center using Vi is equal to 1 by Ci, sigma j is equal to 1 Ci xi, where Ci represents the number of data points in ith cluster. Step 5. Recalculate the distance between each data point and new obtained cluster centers. Step 6. If no data point was reassigned, then stop, otherwise repeat from step 2. Cross validations. Here we can select the number of validations. In the n-fold cross validation, the k-means algorithm is computed n times and the highest accuracy generated is chosen as output. So compared to k-means, the clusters are formed with more accuracy. But as it is time taking, we are going for sampling approach. Proposed algorithm for improving k-means. Sampling. Basic steps for finding initial centroids by using farthest neighbors is as follows. Step 1. Find a unique from all the documents in the corpus. Step 2. Represent the vector space model mapping documents to the unique words. Step 3. Apply the similarity measure and obtain the similarity matrix among the documents. Step 4. From the above obtained similarity matrix, find out the maximum value. The points corresponding to this maximum value will be two initial centers. Step 5. Calculate the means of obtained centers, for example say C, and find the distance from C to all the remaining points. Step 6. The maximum distance is chosen and that point which is contributing to the maximum distance along with C is considered to be the other initial cluster. Step 7. Repeat the steps 5, 6 until specified number of initial centroids are formed. After finding the initial centroids by using farthest neighbors, apply k-means to cluster the documents. We need to pre-process the documents before applying the algorithm. Text pre-processing techniques. Objective. Transform unstructured or semi-structured data or text data into structured data model, that is VSM. Techniques. Collection reader, detagger, tokenizer, stop word, removal, stemming, pruning, term weighing. Pre-processing. We need to pre-process the documents and build vector space models before applying the algorithm. Pre-processing consists of steps: removal of stop words, stemming, prune the words that appear with a very low frequency, etc. Stop words. Many of the most frequently used words in English are worthless in retrieval and text mining. These words are called as stop words. For examples, the, of, and, to, and so on. Why do we need to remove stop words? Reducing in indexing file size. Stop words accounts 20 to 30% of the total word counts. Improve efficiency. These words are not useful for searching or text mining, and these always have a large number of hits. Stemming. The words that appear in documents often have many morphological variants in the bag of words representation of documents. Morphological variants of words have similar semantic interpretations. Stemming algorithms or stemmers have been developed to reduce a word to its stem or root form. The key terms of a document are represented by stems rather than by the original words. Document representation model. In information retrieval and text mining, text data of different formats is represented in a common representation model, for example vector space model. Text data is converted to the model representation. There are three document encoding methods, namely Boolean, term frequency, and term frequency with the inverse document frequency. Vector space models. Vector space model is an algebraic model for representing text documents and any objects in general as vectors of identifiers. A text document is represented as a vector of terms T1, T2, Ti, so on Tm. Each term Ti represents a word. A set of documents are represented as a set of vectors that can be written as matrix, where each row represents a document, each column indicates a term, and each element xji represents the frequency of the ith term in the jth document. Term frequency with inverse document frequency. For example, generate the similarity matrix. Consider that the similarity matrix generated for the 9 document is as shown. Similarity measures. Similar documents are grouped to form a coherent cluster in document clustering. A variety of similarity or distance measures such as cosine similarity, Jacob coefficient, Euclidean distance and Manhattan distance for document clustering. Accuracy calculation. Accuracy is calculated using the following formula. Accuracy is equal to 2.0 into recall into precision by recall plus precision. Applications. In marketing, finding groups of customers with similar behavior given a large database of customer data containing their properties and past buying records. In biology, classification of plants and animals given their futures. In insurance, identifying groups of motor insurance policy holders with a high average claim cost, identifying frauds. City planning, identifying groups of houses according to their house type, value and geographical location. Earthquake studies, clustering observed earthquake epicenters to identify dangerous zones. Conclusion and future work. Here we propose a K-means algorithm for clustering of text documents. In our future work, we intend to apply this algorithm for different similarity measures and study the effect of this algorithm with different benchmark datasets exhaustively. Coming to the execution part of our project, you can see the applet open. This is how our project front end will look like. Here you have to enter the number of clusters and number of validations. The number of validations can be given as you decide, and now select the similarity measure. In order to view accuracies, press cross validation accuracy and sampling accuracy. In order to view the result, click here button at the bottom. A new applet window will open showing the results. You can see majority of the CIS files are clustered in cluster 3 and so on. We provided show clusters button in order to view the clusters. If you press that, a window showing clusters will open. These are the CAC files. These are CRA files. These are CAC files. These are CIS files. Thank you for your attention.